Our topic is talking about the electrostatic force and the Coulomb's law. Now, if we recall in our previous videos on the introduction to electrostatics, we understand that if we have the same charges, then they will repel each other. So therefore, we have the force that charge A exerts on B in direction which is away from the charge. At the same time, we have also the force that A exerts on B. So we have these two identical forces. They have the same magnitude but in opposite direction. So therefore, these objects will travel in opposite towards away from each other. Now, if we have two different charges, then it will attract. So the force B exerts on A, and we have the force that A exerts on B. We have this as the force. So again, these two forces are the same. This is according to the Coulomb's law. So in Coulomb's law, says that the electric force of two interacting charges is directly proportional to the product of charges and inversely proportional to the square of the center-to-center distance between them. And the amount of force exerted by each charge have equal in magnitude but in opposite direction. So therefore, if this is the force that B exerts on A, we have the force that A exerts on B, the same magnitude but in opposite direction. So they will be attracted each other. So therefore, whatever force applied that B exerts on A will be the same force that A exerts on B. And let this be equal to F. F is the electric force. And the unit should be in Newton. And this is vector, remember. So therefore, there must be direction aside from the magnitude. So the law says that this force is directly proportional to the product of the charges. So the charges are QA and QB. So if you multiply these two, the product is proportional, directly proportional to F. The greater the product, the greater the force. But it is inversely proportional to the center-to-center distance between them. So let this be equal to R. R will be the center-to-center distance of the charges. So R is inversely, the square of R is inversely proportional to the force, which means that if the two charges closer each other, then the force will be an increasing force. The smaller the distance, the greater the force. But the greater the distance, which means if they are far away from each other, then the force is getting lesser value and lesser until it will approaches to zero. So in an infinite distance, force is approximately equal to zero. But very close to each other, it will provide a maximum or a greater amount of force. So therefore, the law says that it is directly proportional to the product but inversely proportional to the square of their radius or center to center charges. Now, in order to produce an equation, there must be sign of equality, but there must be take care of the equality. So there must be a constant. We call this as let this be equal to K to balance the equation. Which means if you multiply this K, the right member is always equal to the left member. But in physics, this K means electric constant. Okay? And this electric constant is proportional to the permittivity of the empty space or the vacuum. So in the relation, K is 1 over 4 pi permittivity. So epsilon naught is actually the ability of the electrostatics to penetrate within the medium of a vacuum. okay, or empty space. So it has a value of 8.854 times 10 raised to 12, and the unit is Coulomb square per Newton meter square. So again, the permittivity of empty space is 8.854 times 10 raised to negative 12. So if you substitute this E here for the value of the electric constant, K is electric constant, then it will approximately equal to 9 times 10 raised to 9 Newton meter square per Coulomb square. So therefore, we will be using this one. This is actually 8.9 point something. So round off to 9, we have 9 times 10 raised to 9. And the unit, remember, is Newton meter square per Coulomb square, the unit of charge. Okay? So, therefore, again, this value can be replaced by this constant. The 1 over 4 pi permittivity is the electric constant. So this charge A and B are the interacting charges. So this is the formula for the force of 2-point charges. So two interacting charges, we have this force that have the same value of one charge exerts to the other. So take note, positive negative attract. So the force must be towards each other. Okay? So calculating the magnitude of F, this is the force that charge B exerts on A. So let this be equal to F. And the center to center distance is R. So to calculate the magnitude using the Coulomb's law, the formula is 1 over 4 pi permittivity QA times QB, the interacting charges, divided by the square of their center to center distance. Okay? So take note that this is 9 times 10 raised to 9, and this is Newton meter square per Coulomb squared. So therefore, the unit of R will be cancelled to the unit of K, and the Coulomb squared also cancelled with the two interacting charges product. Then the unit of force is in Newton. Okay? So this is how to calculate the magnitude of force. So all you need to do is to have the two charges, and we have the center to center. Okay, since force is scalar, vector quantity, so therefore it is not enough to describe only by its magnitude. We need to provide its direction. So in order to have a complete description of this force, we have to provide a vector force. So the vector force is we have an arrowhead, and this should be, the magnitude is this one. This is the magnitude, remember, 1 over 4 pi permittivity QA times QB over R squared. And it should be multiplied by R hat. R hat is the unit vector. Remember, unit vector is a vector that has a magnitude of 1, and the purpose is to point in space. So therefore, R will point the direction of force. For example, this one, this is the force. So there must be R hat in this direction. And remember that it has a magnitude of 1. So it doesn't affect the magnitude of the force. It is the same as. So therefore, this one is the magnitude multiplied by the unit vector. So remember, unit vector involves the, in terms of Cartesian, so we have the I hat and we have the J hat. For 3-dimensional, we have I hat, J hat, and K hat. So this R hat involves I hat, J hat, and K hat. Okay? So that's it. What is R hat? Now, R hat can be calculated if we have, for example, we have 2-dimensional problem. So this force is actually lying on the plane of XY plane. So therefore, in this case, we need to have the angle theta from the X, and we have this R, remember. So the R hat is actually in the direction of the force. So this will be the orientation of our R. It is towards the quadrant 1 in this case. Okay? If it is away from the charge, then the R hat will be found directed towards the third quadrant. So depending on the force. So we need this value, remember. because this r hat should be multiplied to the magnitude in order to provide the vector. So what is r hat? R hat will be I j hat plus y x I hat plus y j hat. So what is x? X and y actually are the component of the unit vector along x and along y. So remember, this is unit vector, so the magnitude should be 1. So therefore, these components are actually the components that will provide 1 magnitude of r. So therefore, we assume that r is 1. So the magnitude of 1. So then, x therefore becomes x cosine. Remember, this is adjacent. So the component of x must be cosine. And we have only the cosine value because this is understood to be 1 unit. So 1 cosine theta or cosine theta I hat will be our x component of our unit vector or r hat. And for y, it should be sine because y is opposite. So therefore, this is actually 1 times sine of p j hat. But because 1 multiplied by any number will stay its value, so therefore we can ignore 1 actually. So again, the r hat can be computed using the angle. Take cosine of that, then multiply by j hat, and we have sine of the angle of the j hat. So by the way, this is I hat, and we have this j hat. So in this case, since this is in the first quadrant, so the x component should be positive and the y component also positive. If it is located in the third quadrant, so all of them becomes minus. So it depends upon the direction of r. In our case, we have this all positive because this is in the first quadrant. Okay, so if angle is given, then do it. Now, sometimes r is given. So if r is given in the problem, then you need to have this r hat. You can take the you can rationalize or normalize the vector. So normalizing vector actually is providing a unit vector. So the unit vector the radius r hat or the distance center to center in vector divided by the magnitude of that vector. By the way, r, remember, is a vector quantity. So it should have the direction along x, direction along y. So it involves, actually the vector r will involve I hat and j hat in this case. So if you have that value, simply normalize that vector so that we have the unit vector. Now recall this process in our previous videos in unit vector. So actually, before going to study this electrostatic force, going to succeeding topics, you need to have first the knowledge on the vector analysis because we need that fundamental mathematical processes. We have the vector analysis. Okay? So, we are now ready to solve the problem because we have this formula and we have this r hat. Okay, so problem says that we have 2 point interacting charges. So charge 1, which has a charge of q, and this is positive 75 NC, means nano Coulomb. This is prefix. The unit is actually Coulomb, and we have the prefix of nano. And we have the Q naught is equal to the positive. Again, positive 55 nano Coulomb are separated by distance 3 centimeters. The angle is 30 degrees with find the electric force. Letter A, charge Q naught due to charge Q, and B, force on Q due to Q naught. Okay, so this is the figure. We have this charge. Take note, this is 75 nanocoulomb, and we have another charge Q naught, which is 55 nanocoulomb, and they are separate by a distance of 3 centimeters, and this is lying okay on the two-dimensional axes. We have x, y, and the angle is actually coming from x. We have this 30 degrees. So given the distance center to center, given the two interacting charges, and we have this angle, you are asked to find the force, electric force. So this must be vector. Okay? Otherwise, specified as magnitude, then solve magnitude only. But this one, this is understood to have to provide a vector force, electric force. And this is, we have A and B. A, force on Q, not, okay, due to Q. Due to Q. Okay, we have to reverse this one. This is Q. Change this to Q. First, we will first solve first the force on charge at the origin due to Q naught. So reverse this one. This should be Q due to Q naught. Okay, I think we have to change this. Okay. This should be Q, and this should be Q naught. And this one, letter B, we have to reverse. This is now Q naught, and this is Q. Okay? So therefore, letter A, we are asked to calculate the amount of force on this charge. So this should be force that on Q due to Q naught. Then we have another force. This is letter B. The force on Q naught due to Q. Charge Q, due to this charge. Because this force is due to this charge. And this force is due to the interaction of this charge. And their distance is 3 centimeters. So this is the force on. Okay, and another is, this should be replace. This should be Q, and this should be Q naught. Then we have this again. We have to change this one to avoid confusion. This should be Q, and this should be Q naught. Charge on Q, a force on Q naught due to this charge. Okay, so therefore, take note that to calculate the magnitude is you have to use the 1/4 pi permittivity Q naught over R squared. So all you need to do is to substitute the values. So take note, this is 9 times 10 raised to 9. And the unit is, take note, this is electric constant. Newton meter square per Coulomb square. You have to memorize this one because this is the value of 1/4 pi permittivity. And this one is the charge on Q. Okay? So 75 nano, this is 75 nano Coulomb. Then this Q naught is given as 55 nano Coulomb. Divided by the square of the distance. The center to center is 3 centimeters. You have to square it. Okay, now, look at the unit. The unit is inconsistent. Why? Because we cannot cancel Coulomb. Because this is nano. And this centimeter cannot be cancelled to meter. So all you need to do is to convert this into Coulomb so that it will provide consistent unit. So that we can cancel. So, you have to recall your conversion factor. When we say nano, remember, 1 nanocoulomb is 10 raised to negative 9 coulomb. Okay? So, in order to convert this one, nano, you have to multiply this by times 10 raised to negative 9 in order to produce coulomb. So, you can easily multiply this, then convert it to coulomb. So, if by the way, if this is mu means micro. So, for 1 microcoulomb, it should be 10 raised to negative 6 coulomb. And this centimeter is, 1 centimeter is 10 raised to negative 2 meter. Or 1 meter is equal to 100 centimeter. But in this case, it is convenient to handle the power of 10. Okay, because we all you need to do is to multiply. So, to convert this is to multiply. Times 10 raised to negative 9. So, we multiply this times 10 raised to negative 9. Also this one. And the centimeter to meter, we have to multiply this by 10 raised to negative 2. Then square it. So, therefore, this is already c square. So, you can now cancel the Coulomb. And this one will be squared. So, the meter squared will be cancelled here. So, therefore, the remaining unit is only Newton. So, use your calculator. And the calculator says that force between two forces is 0.04125 newtons. So, therefore, the amount of force here is this one, which is the same as on the other charge, 0.04125 newtons. But this is not the answer. But remember, we need to calculate the electric force. It should be vector. You have to provide a vector so that it will have the, aside from magnitude, we have the direction. This is only the magnitude. So do not stop answering this problem up to magnitude only. Okay? So then, take note that the letter A, we are asked to solve for the amount of force here on Q due to Q naught. So, the force, since the force is tend to move away, then your R should be directed in the third quadrant. So, this is the R hat. Okay, we have already the magnitude. Remember, the magnitude is 0.04125 Newton. So, all you need to do is to find what is R hat. So, because we need to multiply this magnitude, by the way, this value 1 over 4 pi permittivity QA QB over R squared is actually equal to 0.04125 and multiplied by R hat. But what is R hat? R hat is negative xi hat minus yg hat. Why negative? Because this is towards the directed towards quadrant 3. So all components must be negative. So the x component must be negative, also with the y component of the r hat. So since we have this angle 30 degrees, all you need to do is to take cosine of that, then you have I hat, then sine of that angle, then substitute, simplify, then we have this answer. So negative 0.866 I hat minus 0.50 g hat. So this is our unit vector. Multiply this to this value. So substitute this value with this given. So it should be this amount. Remember, this is the magnitude, which is 0.04125 multiplied by the r hat, then distribute, then we have this value. So negative 0.0357 I hat minus 0.2006 j hat. Okay? So the amount of force or on Q due to Q naught is negative because you have to provide the positive term. In algebra, no negative in the first term, so you have to collect the negative, and we have the negative 0.0357 I hat plus 0.0206 j hat. This is the force on what? On Q due to Q naught. This answers the letter A problem. Okay, so for letter B, charge on, by the way, we have, remember, this is Q naught due to Q. So we changed this in previous slide. So reverse this one. So again, for this force, okay, this is the force is the same, the magnitude is the same as the force on Q. So the difference in solution now is R is in the first quadrant. Previously in the third quadrant. But now for letter B, question, R hat should be directed towards the quadrant 1. So all components of your R hat must be positive. So we need to go directly solving the R hat now because we have the same magnitude. So You use the same formula, but this is QB, okay, but they have the same value. So after calculating the R hat, substitute it here. So therefore, do it the same, cosine, sine, calculate. So we have 0.866 I hat plus 0.05 G hat. Almost the same in previous, but this is negative in our previous. This one is positive for X and positive for Y. So multiply this to the magnitude, which is this one, then distribute, okay, and this is our force, okay. So this is positive. Take note, they have the same magnitude but in opposite direction. This is negative and this is positive, okay. So the same magnitude but in opposite direction. So these are the answers to the problem. Now all you need to do is to use the Coulomb's law. If you're asked this kind of problem, then after solving the magnitude of the force, then find the unit vector. So the force can be, the unit vector can be directed in the first quadrant, maybe second, third, or fourth. So be wise on using calculating your R hat, especially the components X negative, X positive. You have to be careful on it. Okay, so we can verify this if this is correct. To verify if this is correct, then we have to calculate the magnitude and direction. So the magnitude, remember, in our vector analysis, to find the magnitude of this force is simply square this X component of force and square the Y component, then take square root because it forms Pythagorean theorem. So therefore the answer is, look at this one, the same, 0.0412. This is the magnitude we calculated in the previous slide. And the angle, to verify if this is 30 degrees, you can take the cosine, inverse tan. So inverse tangent of Y, this is the Y, 0.026 by 0.035. Take inverse tangent, then the answer is very close to 30. Okay, so it's your task to check this. Again, to check is inverse tangent of this 0.02 Y component divided by the X component of force. Okay? Now, this is only 2-point charges. What will happen if there are other charges here and you are asked to calculate the amount of force, or 2 or more surrounding charges? So in that case, we call that as the superposition of electric forces. Superposition means we cannot say only one force that acts on the charge. It can be 2 or more depending on the surrounding charges. If we have 2 interacting charges, this one, for example, then we have one force. But because we have this one, we have another force. The number of charges surrounds the charge will be the number of forces acts on that charge, because each charge interact a force on charge 1. So we call this as superposition of electric force. The problem says, given the charge 1 is 1 as at the origin, is 8 microcoulomb. Charge 2 is 5 micro. Charge 3 is 6 microcoulomb. Letter A, calculate the net force. So again, net force means vector, but it is the net because it should be, by the way, the net force is the vector sum. It is not an algebraic sum because force is a vector quantity. Calculate the net force on charge 1. This is the charge 1 due to charge 2 and 3. So this is 2 and 3. So we are focused on this force on at the origin. Sometimes questions may ask for the force on charge Q3 or maybe Q2, but in this case we are asked to calculate the force on charge 1. So that's it. Then letter B, calculate the magnitude and direction of the net force. Okay. We can easily solve this letter B if we have already calculated the net force on charge 1. Start. Okay. Now remember that we have charge 1 and charge 2 interact each other, so we have the force repel. It is away, so this is tend to move in the X direction. negative x. So this is the force that 2, take note, 2 exerts on 1. So that if sub 21 means the force on force that 2 exerts on 1. Now, since we have another charge, then we have another force. Okay? And take note, this is positive different charges. So therefore, attract. So the force must be towards. And this is the force that 3 exerts on 1. These are the forces acts on this charge. So this is again of superposition of electric forces. Okay? There are two forces because the number of charges are the number of forces. So what will you do on this problem? So since this is forces, so therefore we have to find the vector sum. So again, you have to recall your vector analysis again. Finding the vector sum of two forces. So the best thing to do is to find the magnitude of force that 2 exerts on 1 using Coulomb's law. So analyze this with charge 1 and charge 2 only so that you can calculate this one. Then after that, calculate this one using charge 1 and charge 2. So remember, we need R. The R of 2, 1 is 4, and the R of between charge 1 and 3 is this side. So you have to calculate that one. So that this is R radius between center to center between charge 1 and charge 3. So we have take square because this is right triangle. So square root of 4 square plus 3 square is actually 5 centimeter. Okay? 4 cm, 3 cm, square root, the sum their squares, then we have 5 square. Now for the distance, these are the radius or center to center, charge 1 to charge 2 or R12 is 4 cm. So this is already given. So we have now the charges and we have the distances. So we are now ready to solve for the force. By the way, we still need to calculate the angle. So the angle can be calculated using inverse tangent, 3 over 4, opposite over adjacent, so that this will be the angle. So that angle is 36.87 degrees from positive x-axis. Okay, so these are the informations. From the given informations, we are able to calculate this one, the R and the angle. So we are now ready to calculate the force that 2 exerts on 1. So 2 force that 2 exerts on 1, so use the formula, the Coulomb's law, 1 over 4 pi permittivity, this is constant. Q1 is given as 8, Q2 is given as 5 micro, and R12, this is the center to center distance between charge 1 and charge 2, 4 centimeter square. So substitute. So this 8 was, the 8 microcoulomb was already converted to coulomb. So remember, in our previous problem, to convert the micro, you need to multiply 10 raised to 6. For nano, 10 raised to 9. So we multiplied the conversion factor to convert micro to coulomb. So this, therefore, 5 must be multiplied by 10 raised to negative 6. And the 4 cm will be multiplied by 10 raised to 2 for the meter, conversion to meter. So we are now consistent, so we are now ready to calculate, multiply all numerator, divide by, remember this should be squared because this is square. So we come up with 225 newtons. Okay? So this is the magnitude of force that 2 exerts on 1. This one. Now what is the force that 3 exerts on 1? So you have to use again Coulomb's law. This is still the constant, the same value. Q1 is the same also. This is 8 micro, while Q3 is, this is given as 6. And R3, 1 to 3, is 5 cm. This should be the distance to be used because it is center to center. So then, substitute, then convert that to coulomb, micro, from micro to coulomb, then 10 raised to 6, negative 6. And the 5 cm times 10 raised to negative 2 to convert it to meter. Then calculate 172.8 newtons. So, these are now the magnitude of the forces on the interacting charges. So, this is again, 2, 1, the magnitude of the force that 2 exerts on 1, And the force 3, 1 is the force that charge 3 exerts on 1. Okay, so then, this is it. We have this force that 3 exerts on 1, 172.8 newtons. And this is the force that 2 exerts on 1. And remember, the angle is 36.89 between them. So we are now ready to find the net force. So, look at this one. Graphically, the net force is somewhere in this point. This is drawn at to scale, but approximately we will this is the possible force, net force. So we have the magnitude, the force, and we need to have this direction. Okay, but you can do it using the vector. Then after that, we can find the magnitude for letter B and the direction. So how will you compute the net force on, so the net force of these two forces due to these charges? Now there are many ways to solve. Remember, in vector analysis, we can use the graphical, we can use analytical, but the best thing to do is to involve the unit vector. So we will use the vector sum involving the unit vector. So first is to what? Remember that the net force, this net force vector, is the vector sum of this. This is force, so the vector equivalent to this plus the vector of this, the geometric sum will be the net force. Again, recall your vector analysis on this. Reminders, this is not an algebraic sum. This is geometric sum. It involves angle. Okay? So, first, what is the vector force that 2 exerts on 1? This one. Remember, this is towards the negative x. So, to find the vector is to multiply the magnitude, which is 225 multiplied by negative I hat, because this is directed towards negative. And the j component or the y component, the magnitude of y component is 0. So this term will be cancelled out. So we have only the force that 2 exerts on 1 vector is negative 225 I hat. Okay, so we have now this value. So we can substitute this one. Then next is to calculate what is the force vector that 3 exerts on 1. So look at this one. Recall your vector. The x component of this vector is actually, by the way, this is towards the positive, the first quadrant. So the I hat must be positive and the j hat must be positive. And this one, take note, this is the x component of f. So it should be the magnitude, which is, in this case, the magnitude of 3,1 is 172.8 multiplied by the cosine of the angle. The angle is a reference angle from x, so therefore you have 36.89, then added by the 172 again, the same, but this is sine of the same angle. So therefore, this is the vector force that 3 exerts on 1. Okay? In our previous slide, we have only the cosine. Why? Because it is unit vector. But this one, this is not a unit vector. So you have to use the magnitude. In our previous, r hat, we have no values here, but it is understood to be 1 because magnitude of unit vector is 1. But this one, the magnitude is 172.8. Okay? So simplify. We come up with 138.20 I hat plus 103.73. This is the force that 3 exerts on 1 vector. So, okay. We are now ready to substitute. Replace this force that is 2 exerts on 1, this one, negative, and this F. Okay, so we are now on the way to calculate the vector sum using the vectors in terms of unit vector. So substitute this equation. So we have this F1 and this is F31. Now we can remove the grouping symbol, then we can combine like terms. So we can combine the 225 and 138.20 I hat. So we come up with negative 86.8 I hat plus 103.73 J hat. So the unit must be, by the way, this should be Newton. But remember, this is negative. Okay? So therefore, we can eliminate the negative so that the first term will be positive, but this will becomes negative. So we have 86 negative, quantity 86.8 I hat, minus 103.73 G hat, and the unit is in Newton. This is the answer. This is the net force on charge 1. So notice that, look at this one. This is what? Negative X component. So therefore, it should be towards left. And the Y component is upward. So therefore, F force must be in the second quadrant. Because negative X, positive Y. Okay. So, letter B. Letter B, calculate the magnitude. So, we can easily solve the magnitude because we have this vector. By the way, the full description of force, it should be expressed in I hat and J hat. Because in here, we have already the magnitude and we have the direction. So, in the direction actually, you can find the angle of this and you can find the magnitude. So, let's do it. So, letter B, to find the magnitude, use the principle. Recall your vector. To find the magnitude is to have the square root. Square the X component, square the Y component, then add, then take square root. So, therefore, we have this magnitude. So, this is the magnitude of the net force. Okay? So, when you look at this one, if you add this directly, that 225 plus 172.8, it is not equal to 135. Again, because this is not an algebraic sum. This is a geometric sum. So, this is the magnitude. And the direction is this one, gamma. So, what is this angle? From X. So, in order to have this direction, we use the tangent, arc, inverse tangent of what? The Y over X component. So, Y component of the net force, which is this one, divided by the X component of the net force, which is 86.8. So, then calculate, and the answer is 50 degrees. Okay? Look at the description. The 50 degrees is from negative X. So, from negative X in quadrant 2. So, therefore, this one. So, this is the complete description because we can have the negative X in quadrant 3 also. So, therefore, you have to specify where is your angle coming from and in what quadrant located is the net force. So, therefore, these are the answers to the problem. Okay, so the most important in this topic is always remember that we have the Coulomb's law to solve only the two interacting charges. So, we can solve the force here due to this one. Now, if there's another force charge, then solve again. And after that, you have to use our vector analysis to solve for the net force. So, you are all encouraged to go first the requirements, which is the vector analysis. We have series of videos in vectors analysis before going to solve this problem. Okay? So, for your practice, I have this problem. Now, you are all encouraged to solve this problem. This is the charge 1. And we have 3 surrounding charges. And we have this given informations. So, all you need to do is to find the force on this charge. You have to calculate the magnitude and direction. So, to answer the magnitude and direction, you can use again the unit vector. So, find a vector first, then solve the magnitude and direction. Or you can go directly with magnitude and direction using component method. Okay, so that's it. Good luck. The next topic is electric field.